On this front side of the quiz, we're going to be solving by factoring. That means the first thing we do is we factor this part right here, right? It's going to equal 0. So what I need is two numbers that multiply to 70 and add to negative 17, right? Because there's just a 1 out in front here, so this is x times x is x squared. Now, these two numbers have to multiply to a positive and add to a negative. The only way that's possible is negative times negative, right? Negative times negative is positive, and we're adding negatives and more negatives. So then I just need two numbers that multiply to 70, add to 17. That's going to be 10 and 7. And now I have a number times a number equals 0. So if this number equals 0, right, then this 0 times a number would equal 0, perfect. Or this number can equal 0. But remember, this is a number here, and this is a number here, and one of them has to equal 0. So then when we solve, here I get x equals 10, or x equals 7. And a great habit to just list them in order from least to greatest. So x equals 7 or 10. Let's do the next one. Very much the same. Again, I have just x out in front, so it's going to be, just x squared out in front, so it's going to be x times x. I need two numbers that multiply to negative 55, add to negative 6. Right away, I observe that since I'm multiplying to a negative, it's going to be a positive times a negative. So now I need two numbers that multiply to 55, and when I subtract them, because they're different signs, I get 6. So those numbers are 5 and 11. And since I want them to add to negative 6, I'm going to make there be more negatives than positives. I'm going to make the bigger number the negative. Okay, and then I have number times number equals 0. So either this number must equal 0, or this number must equal 0. Right? And definitely start to observe the patterns, right? This is x plus 5. The solution becomes x equals negative 5. And why is that? Because look, if this was a negative 5 here, negative 5 plus 5 would equal 0. And here, if I factor and I get x minus 11, this is 11, positive 11. Why? Because if I put 11 right here, 11 minus 11 would equal 0. Okay. Here I have just x squared out in front. So this is this, and then I need two numbers that multiply to negative 25 and add to 0, right? There's a plus 0x here. Okay, so those two numbers are positive 5 and negative 5. So again, I have, this is either this number equals 0 or this number equals 0, right? And I'm going to solve. In this case, I get negative 5 and positive 5 are both solutions. So we'll list them in order from least to greatest, negative 5 first, then positive 5. Here's one that's a little bit different, and it's because there's not just an x squared out in front. So just like always, right, like it's always x times x equals x squared. So now this times this has to equal 2x squared. Well, that's going to be 2x and x. And these two numbers still have to multiply to this, right? But the thing is that now, right, when I multiply, like in the past when I multiplied, this was like, oh, negative 11x plus 5x. Oh, that's negative 6. But now there's this 2x in the mix, so changes things. I'm going to observe the signs first. Everything's positive here. And numbers that multiply to 20 can be 1 times 20, can be 2 times 10, can be 5 times 4. So let's just start, let's put a 2 and a 10 right here. Let's see, that would be 20x plus 2x. Oop, that'd be 22. That doesn't work. Let's try switching the 10 and the 2. That'd be 4x plus 10x. Ooh, close. That's 14, but it's not 13. So I tried 10 and 2 both ways. Let's try 5 and 4. 2x times 4 is 8x plus 5x. Oh, hey, that's 13. Perfect. So this is all good. The factoring's good. So now I have number times number equals 0. So 2x plus 5 equals 0, or x plus 4 equals 0. So if I solve this one first, and I need to make sure not to forget the last step here, right? Because look, on all these, I just had one-step equations. But here, there's still a 2 here being multiplied by x. So I'm going to go ahead and divide. Negative 5 divided by 2 is negative 2.5. And negative 4, again, great to list them from least to greatest. So that would be negative 4 and then negative 2.5. All right, and last solve by factoring here. I know that this times this has to equal this, so that's going to be 5x and x. And then this times this is going to equal negative 18. Oh boy. Okay, so first of all, it's negative, so that's going to be one positive, one negative. I might have to switch those later, but we'll find out. It could be 1 times 18, could be 2 times 9, could be 3 times 6. Let's try 3 and 6 first. So let's say I put 3 here and 6 here. That would be negative 30 plus 3. Ooh, that's negative 27. Nope. Let's put the 6 here and the 3 here. That's 5x times negative 3. That's negative 15 plus 6. Ooh, I think we're on to something here. Look, let's make this neater so I can focus on it. That's negative 15 plus 6. That's negative 9. I want it to be positive 9. So let's go ahead and switch just the signs. So now 5x times 3, that's positive 15. And let's just neaten this up. And then negative 6 times x, that's negative 6x, and that's positive 9, and that's what I wanted. So perfect. This is factored. So we're all set, and now we're gonna go ahead and solve. So I'm going to add 6. 5x equals 6. I'm going to divide by 5. And 6 divided by 5 is 1.2. I'm going to subtract 3. So x is negative 3 or 1.2. All right. Here we go. We're going to be solving by factoring to find the x-intercepts, because remember the x-intercepts are the same as solutions. So we can just go ahead and literally do exactly what we just did. Okay, so I'm going to factor. I need two numbers. Look, this is just an x out here, x squared right here. So I need two numbers that multiply to negative 15 and add to 2. That's going to be 1 positive, 1 negative. And that's going to be 5 and 3. Okay, so then I solve, right? Either x plus 5 equals 0 or x minus 3 equals 0. I'm going to subtract 5 and add 3. And so my two x-intercepts are negative 5, 0, and 3, 0, right? Like this, look, this was y equals all this. I plugged in 0 for y. That's how I find x-intercepts, always. Okay, so this is my y is 0. My x is either negative 5, so here's negative 5, 0, and 3, 0. Okay, my y-intercept, I'm going to plug in 0 for x, so that's 0 squared plus 2 times 0 minus 15. This is 0 plus 0 minus 15. So that's x is 0, y is negative 15. I'm going to graph that. Okay, and then the axis of symmetry is negative b over 2a. So let's take a look. What's my a and what's my b here? In the equation, it's always y equals ax squared plus bx plus c. So my a is 1 and my b is 2. All right, a is 1, b is 2. Okay, so negative b, that's negative 2, right? B is 2, so this is negative, so it's negative 2, over 2 times a. So that becomes negative 2 over 2, which is negative 1. So my axis of symmetry is x equals negative 1. So that's this line right here. Look, here's the line x equals negative 1. And we can see this is looking right. You see how the axis of symmetry is landed right in between my two x-intercepts? That's what I want. I could have even started at my x-intercepts and just gone in 1, in 1, in 1, in 1, in 1, in 1. Oh, there it is, axis of symmetry. And then my vertex, here's the thing. I know about my vertex. My vertex is going to land somewhere on the axis of symmetry, right? Because that's how parabolas are. So I know that my vertex, that the x value is going to be negative 1. So what I'm going to do is I'm going to write this equation, x squared plus 2x minus 15, and I'm plugging in that x value, right? Because I already know the x value. Now let's just do the math. Negative 1 squared is negative 1 times negative 1. That's positive 1. 2 times negative 1 is negative 2 minus 15. And then if I do 1 minus 2, that's negative 1, minus 15, that's negative 16. So my vertex is at negative 1, negative 16 right here. And everything is looking beautiful. I can make my graph even a little bit neater by taking this y-intercept and just kind of reflecting it over the axis of symmetry right there, just to kind of give myself something to aim for. I'm going to come through my y-intercept, and here is my parabola. Okay, looking pretty good. Okay.